Today we're looking at matrix operations. So the first thing that we'll need to look at is and talk about is what are matrices. So first, matrices is just the plural of matrix, and it is a probably different form of math than you're used to. So it looks at just a matrix, which would look something maybe like this, with numbers inside. So we might have numbers like 3, 2, and 7, -1, 0, 4, 6, 12, and 1. And we might call this matrix A. So it's a capital A names the matrix. This is matrix A. And there's a few things that we want to talk about with it. So first, what might be a little bit odd here is that it is the numbers 3, 2, 7, not 327, not 32 and 7. So as you write your own matrices, you want to make sure to keep that separate. The second would be that this is not any kind of fraction or anything like that. It's not 3 over -1 over 6 or something weird like that. It is just exactly what it says. 3 is a single element. An element is just a single part of our matrix. And the matrix has a size, right? This is a specific size. That is called our dimensions. So our dimensions here, this is a 3 by 3 because it has 3 rows, 1, 2, 3, and it has 3 columns, 1, 2, 3. So this is rows by columns. And for a general matrix, sometimes we'll call this M by N. Again, an element is just a single part of the matrix. So something like 7. Right? So 7 is an element of the matrix. It is the element A subscript 1, 3. So 1, 3, this is not 13. This is row 1, column 3. Right, so again, 1, 2, 3, 1, 2, 3. Across are our rows up and down. Think columns. Columns go up and down. If you're looking at like a house with columns, the columns go straight up and down, or like the White House or something like that. So element 1, 3 is 7. If I wanted the element in matrix A 2, 2, this is the middle, the second row, second column, which would be 0. Again, I could ask this for any of these. Let's do 2, 3, and 3, 2. So row 2, element 3, is 4, and row 3, element 2 is 12. Different operations that we can do with matrices. So we can do addition and subtraction. And luckily this works basically exactly how we would expect it to. So there's one catch later on. If matrices come up on the ACT, typically it is somehow that I've seen somehow in this form with addition or subtraction. So say we have two matrices, 1, 4, 8, and 3, 7, 4. And we want to add that to the matrix 2, 5, 4, and 1, 0, 3. With matrix addition, you just add the elements in the same spots. So if you have an element 1, 1, you add that to element 1, 1 from the second matrix. So here we get another matrix, element 1, 1 plus 1, 1 from the second is 3, 1 plus 3. So 1 plus 3. Then we have 4 plus 5, which is 9. And the last one is 8 and 4, which is 12. Do the same thing in the bottom row. We have 3 plus 1, which is 4, 7 plus 0, which is 7, and 4 plus 3, which is also 7. And that's it for addition and subtraction, or addition, right? If we did subtraction, we might use the same two matrices, so 1, 4, 8, 3, 7, 4, minus 2, 5, 4, 1, 0, 3. And then we have 1 minus 2. 1 minus 2 is negative 1. 4 minus 5 is also negative 1. And then 8 minus 4 is 4. Then we have 3 minus 1, which is 2. 7 minus 0, which is 7. And 4 minus 3, which is 1. So again, element to element, they just match up and subtract. So element 1, 1 from the first matrix, subtract element 1, 1 from the second matrix. Question I could have asked from the start, the size of all of these matrices, so how many rows do each of these matrices have? They have 1, 2 rows. So its size is 2 by how many columns? 1, 2, 3. So all of these have size or dimension 2 by 3. All right, let's look at another one. If we had 1, 2, 3, 4, and we wanted to add it to 1, 2, 3, 7, 8, 9. So you might start by thinking of it the same way. Well, I'm going to add element 1, 1 to element 1, 1. That would be 1 plus 1. And then I'm going to add element 1, 2 to 7, right? So 2 plus 7, 3 plus 2, 4 plus 8. And then what would I add to 3? What would I add to 9? Well, this is a problem, right? Well, what's the problem here? The problem is that the first matrix has 2 rows and 2 columns. The second matrix has 3 rows and 2 columns. So because these have different size, 2 by 2 and 3 by 2, this is not possible. In other words, in order to add or subtract matrices, the matrices must be the same size. They must have the same dimensions. That's not true here, and therefore it doesn't work. Last thing is called scalar multiplication. This would be something like 3 times a matrix. Looks like I'm using the same one again, just to show that we can use all of this different stuff. And this is just to basically distribute this 3 into each of these elements. So we have 3 times 1, we have 3 times 4, we have 3 times 8. We have 3 times 3, we have 3 times 7, and we have 3 times 4 again. So again, scalar multiplication is just to distribute that 3 in to every element of that matrix. So what if we had something like 3, and we'll use that matrix, 1, 4, 8, 3, 7, 4. Let's do minus 2 times 2, 5, 4. Sorry, that 4 should be a little bit further off that 5. 1, 0, 3. So I do the scalar multiplication first, right? Multiplication does typically come before addition and subtraction. So I get the matrix I just was talking about, 3, 12, 24, 9, 21, and 12, minus, we have 2 times 2, which is 4, 10, 8, 2, 0, 6. 3 minus 4 is -1. 12 minus 2 is 2. 24 minus 8 is 16. Then we have 9 minus 2, which is 7. 21, 6. And that is our matrix. Lastly, there's something that's interesting about matrices, and that is this question on typically addition and subtraction have some values of being commutative, right? And so the question is matrix A plus B equal to matrix B plus A? And is matrix A minus B equal to B minus A? Now, simply put, you can make up whatever matrices you want for A and B. So A, we might call 1, 4, 3, 2, and maybe matrix B we'll call 2, 3, 0, -1. So is A plus B? What is A plus B? Well, A plus B is the matrix 1 plus 2, 4 plus 3, 3 plus 0, and 2 minus 1, and B plus A, sorry. B plus A, 2 plus 1, 3 plus 4, 0 plus 3, and -1 plus 2 is 1. So those seem to be the same. So yes, it looks like A plus B equals B plus A. Is A minus B the same as B minus A? Well, A minus B, this is 1 minus 2, 4 minus 3, 3 minus 0, and 2 minus -1, which is 3. And B minus A, so this is 2 minus 1, which is a +1, and already these matrices are not the same because 1 is not the same as -1, but we'll keep going. B minus A, so 3 minus 4 is -1, 0 minus 3 is -3, -1 minus 2 is -3. These are not the same. No,